Outlier correction refers to identifying and adjusting demand data that deviates significantly from the expected pattern, as these outliers can distort the accuracy of forecasts. In demand planning, outliers often result from errors, unusual events, or anomalies that don't represent typical customer behavior or market trends. Addressing these outliers ensures more reliable and realistic demand forecasts. Outlier correction in demand planning has several significant benefits, as it helps ensure accurate forecasts, reduces errors, and optimizes supply chain efficiency. Methods to identify outliers. 1. Statistical methods. Z-score method example. Imagine you have monthly demand data, 100, 120, 110, 400, 115, 105. Calculate the mean, mu equals 175. Calculate the standard deviation, sigma equals 120.21. Z-score for the outlier, 400. Z equals 400 minus mu slash sigma. Z equals 400 minus 175 slash 120.21. Z equals 1.87. If a Z-score threshold of plus or minus 2 is used, 400 might not qualify as an outlier. However, if a tighter threshold, for example, plus or minus 1.5, is applied, it would be flagged. IQR method example, for the same dataset. Sort data, 100, 105, 110, 115, 120, 400. Q1, 25th percentile, 107.5. Q3, 75th percentile, 172.5. IQR equals Q3 minus Q1 equals 65. Outlier thresholds. Lower, Q1 minus 1.5 times IQR equals 107.5 minus 97.5 equals 10. Upper, Q3 plus 1.5 times IQR equals 172.5 plus 97.5 equals 270. Any data point beyond this range, 10 to 270. For example, 400, is flagged as an outlier. 2. Time series analysis. Suppose the weekly demand for a product typically ranges between 300 and 500 units due to seasonal patterns. In 1 week, the demand spikes to 1,200 units due to an unplanned promotional event. A moving average, for example, a 3-week average, might show a gradual trend around 400 units, which highlights that 1,200 is an anomaly. Advanced methods like seasonal decomposition of time series, STL, can highlight this deviation. 3. Visual inspection. Using a time series plot, you observe a sharp peak or valley. For example, during the COVID-19 pandemic, demand for sanitizers spiked in March 2020. Such peaks, visible in plotted data, can be marked for adjustment or exclusion based on context. Smoothing techniques. Moving averages example. For given original demand, 100, 120, 110, 400, 115, 105. Calculate a 3-period moving average. Period 3 moving average equals 100 plus 120 plus 110 slash 3 equals 110. Replace 400 with the average of the prior and following periods. 110 plus 115 slash 2 equals 112.5. Exponential smoothing example, apply a smoothing factor, alpha, to reduce the influence of the outlier. SD equals alpha times DT plus 1 minus alpha times SD minus 1. Where SD is the smoothed value, DT is the actual demand and alpha is a smoothing constant ranges between 0 and 1. 2. Capping and flooring. In a dataset where typical demand ranges between 50 and 150, if you see a value of 500, cap it at 150. Original, 50, 120, 500, 100, 75. Capped, 50, 120, 150, 100, 75. 3. Substitution with contextual data. Imagine an outlier occurred during a specific event, such as a festival sale. If demand spikes to 2,000 units, from unusual 400, you could substitute it with the median demand during past festivals, say 1,500 units.